Today we're going to talk about the constant of proportionality. So that's what I'm going to title my notes as. The constant of proportionality. This can also be called the constant rate of change. And before we even get started with this, I want to remind you guys what the word constant means. We hear that outside of the math class as well. If I were to say that your teacher has to constantly tell you to stay focused, that means that over and over again you may have heard your teacher say, time to focus, keep working, stay focused. It's the same action that's happening over and over and over again. So it's the same repeated action. And proportionality we're going to show with equivalent ratios. So when we are comparing two things and they are being compared at the same rate, we show constant of proportionality in three different forms. We're going to use an equation, we're going to use a table, and we also will see a graph. Your equation that you will always see, and it'll actually be on your formula chart, is constant equals your y over your x. So K means your constant. So I'm going to add that here as part of my notes so that I don't forget. K equals constant. So the variable K, anytime we see that, that's going to represent our constant. You may also see this as y equals k times x. Those are the same equations. Think about if I wanted to try to get this y by itself here, then I would have, and I'm going to write this in pencil just to show you. If I wanted to isolate my variable here and get y by itself like it is in this equation, I would do the inverse operation or the opposite operation to move my x, which means I would have to multiply since they're currently being divided. I'd have to multiply both sides by x. Well, when I do that, these two will cancel out and I'm left with y equals k times x. So that's how I know that these two equations are the same. The scenario that I'm going to use to show you this is dollars to quarters. So I'm going to compare dollars to quarters. So if I have, we're going to say that my K is what we're looking for. My Y is going to be my Y equals my quarters, and my X equals my dollars. And we're going to see if this is going to have a constant relationship. I'm going to show you an example, and I think it will make more sense once we see this example. So I have dollars and quarters. If I have $1, we know that's 4 quarters. If I have $2, we know that's 8 quarters. If I have $3, we know that's 12 quarters. If I have $4, we know that's 16 quarters. $5 is 20 quarters. $6 is 24 quarters. So to show you that it is a constant relationship, according to my equation, my constant equals my y divided by my x. Because just a reminder, I know that this fraction bar means to divide. When you're looking at a table, unless it's otherwise told, my x is on top, my y is on bottom. So when I try to use this equation of my y divided by my x, I can pick any set of ordered pairs. So I'm going to just focus on this first one. My my constant equals my y divided by my x. So when I write that in an equation, I write that as 4 divided by 1. 4 divided by 1 is 4. In order for this to be a constant relationship, in order to have a constant relationship, it has to this relationship has to happen more than once. So if I look at another ordered pair, so another x and y, if my constant is still 4, then this could have a constant rate of change or show a constant of proportionality. So if I once again divide my y by my x, so that's 8 over 2, 8 over 2 still equals 4. If you notice, no matter what, anytime I divide my y by my x, so if I do 12 divided by 3, I still get 4. So because I have the constant quotient of 4 every time I divide y divided by x, the relationship between dollars and quarters shows a constant rate of change or a constant of proportionality. So within an equation, if we use our constant of 4, we would show that as y equals my constant times my x, or y equals 4 times my x. Anytime I see my y equals a number times my x, if there's nothing added or subtracted to it, this will be a constant relationship. If I were to graph this relationship, we're going to have 0. My x says it's dollars. My y says it's quarters. And for dollars, I'm just going to show 1, 2, 3, 4. My quarters, if I go to 4, I need to go up to 16. So we're going to count by 4s for this case. So 4, 8, 12, 16. If I make these plots, so I'm going to go to 2 and 8, 3 and 12, 4 and 16, what do you notice is happening? It's making a straight line, so it's a linear relationship, and it's also going to end up going through the origin of 0, 0. Because think about that. If I have $0, I also have 0 quarters. A constant of proportionality also goes through my origin. They always do. So proportional relationships if it's proportional, it must go through the origin it must I wrote musk, but that says must. Have a constant So that means when I do constant equals y over x, it must have the same constant with a table. And with an equation, it must show y equals kx with nothing being added or subtracted. So if I showed you an equation that said y equals 8x plus 1, because there's something added and subtracted, that's not proportional. But if this was just y equals 8x, since there's nothing added or subtracted, that is a proportional relationship. So if we turn our page, I'm going to show you some quick examples. If I had a table, because tables are what you're going to mainly be working on here, and we're just going to say this was time and this was money. So if I had I'm just going to write this table and then we're going to talk about it. 216, 3, 24, 4, 32. So if this was the table that you were given, and you needed to tell me, is it proportional? In order to figure this out, I would need to use the equation of k equals y over x, which means I need to divide my y and my x, and if I get the same value each time, then it's going to be a proportional relationship. And just a reminder, my x is on top, my y is on bottom, unless they've told you otherwise. So if I look at this ordered pair, this would be 8 divided by 1. The trickiest part of this, the common mistake that we see as teachers, is that you just do 1 over 8. Make sure you're doing your y over your x. If I divide my y over my x, I get 8. If I move on to the next ordered pair and I do 16 over 2, so y over x, I get 8. And it's important to try a few of these. Don't just do 1 or 2. I would try for 3. So if I do 24 over 3, I still get 8. So since this is getting me the same quotient for every ordered pair, my constant is going to be 8. So is this proportional? Yes. You're also going to see as part of your worksheet today that they're going to ask for you to write an equation. Remember, the equation that we're going to use is y equals my constant times x. The x and y, we're going to leave as x and y, because if I look at my table, do I have the same x or the same y? No, that number itself actually changes. So when I write my equation, I'm going to leave my y and my x. My constant, that is the same for every ordered pair. So for that case, I can put y equals 8x. I have nothing added or subtracted, and we're going to go into more detail later about how to write an equation that does have addition or subtraction. So if I were to also then tell me time represents which variable? In this case, time represents my x. Money, that represents my y in my equation. It's really important that we know what our x and our y represent within our table. If I were to then make a table with this, or a graph with this, my x is time, my y is money. I need to go up to 4 with my x-axis, so 1, 2, 3, 4, and I need to go all the way up to 32. I don't have 32 lines, but I bet you we could count by 8. So if we go 8, 16, 24, 32. That's as high as I need to go. Well, 1 is with 8, so 1 and 8, 2 and 16, 3 and 24, 4 and 32. This is still creating a line, and if I have 0 hours that I'm working, then I get $0. So since it is going to go through my origin, this shows a proportional relationship. So what would it look like if it was not proportional? So I'm going to show you one quick example of when it's not proportional. We're going to talk about time and distance. And let's just say we had an example of a car driving down the road. Well, in 1 hour, let's say in 1 hour, I drove 67 miles. Then let's say in 2 hours, I drove 120 miles. And then let's say in 3 hours, I drove 195 miles. And then we can say that in 4 hours, I drove 220 miles. In order to find out if this is a proportional relationship, remember, I have to have the same constant. There's been a lot of bells and phone ringings and everything. This has been an entertaining video for y'all. Remember, in order for it to be proportional, I have to have that same constant, which is y over x. So I'm going to look at this ordered pair, and I'm going to divide 67 by 1. Well, 67 divided by 1 is 67. Okay? Well, let's see if the next one works. With my next ordered pair, I need to divide 120 by 2. Y divided by x. That equals 60. 60 and 67 are not the same number. So is it proportional? No. Which means I don't have an equation, and I don't have, but I can tell you what my variables are. So for time is still my x, and distance is still my y. It's always really important to identify what your x and y are so we know what we're talking about. But this is not a proportional relationship because when I divided my y by my x, I did not get the same number. So it doesn't have a constant rate of change between my x and my y. Remember, if you ever have any extra questions, you can always talk to your teacher and ask plenty of questions. When you're done with this, there's a white worksheet that says constant rate of change that your teacher has where we can practice this. Remember, ask questions if we don't understand, and you can always rewatch this. Have a great day, and thanks for watching.